Good day, folks. This is video number 9 in the motion design playlist associated with the dynamics model in 3D Experience. When you use the motion design application, the concept of marker becomes very important and exists all through the development of the application. So the question is, what is that marker and how is it used to specify initial condition of a dynamics problem? Now, uh, it is a basic explanation. It doesn't cover all the aspects, but at least it sheds some light on what this thing is about. Now, when you go to motion design, you end up with a ribbon that you see at the bottom. Uh, at the bottom of the screen, you see this ribbon, and in the mechanism tab, you will see marker specified as you scroll to the right. There it is. Now, um, this marker only appears in motion design. It does not appear in any other stuff that you may have done in assembly design, in part design, etc. But as I said, when you start motion design application, this marker becomes critical. Okay. Now, to see your markers once they're made, by the way, you have to uh, click on this application options, this icon here, and the marker will be appearing or disappearing from the screen. Now, I've done these in the first 8 tutorials, but anyway, I'll go through it again today. All right, so that is the focus of this video. And later on, I'll show you how does it come into the picture or how it can come into the picture when you have to specify initial conditions. Okay, when you click on the marker icon, this dialog box opens up and you can either manually specify the marker. Essentially, marker, think about it as a right-handed coordinate system, some kind of a coordinate system, access system, which you can specify its origin and the directions, or you can specify it through geometric features of your model. We will see that in a minute. Okay. There is help there, but the help is very skimpy, and well, I don't know. I'll explain that in the context of this problem. Okay, so we have, let's say, a surface down there, 2 meter by 2 meter. We have a block up there, which is with those dimensions, doesn't matter what they're made of. And what you want to do is you want to, from a height, you want to give it initial velocities and make this block fly, and eventually will hit the plane down there. Okay, I'll explain that in the context of this example. Now, initial conditions you'll see that in some of the earlier tutorials of the 8 tutorials where the initial condition is discussed, but we'll do it again. Initial condition is in mechanism tab, there is an icon, initial conditions right there. And then once you specify initial condition, you can see it, you can look at it by going to initial state solve, okay? And when it comes to specify initial conditions, as you will see, you can either do it in terms of marker or you can do it in terms of joints. And notice that you are specifying some stuff here. Position, initial velocity, etc. We'll see that in a minute. Now, because that block eventually is gonna, it may hit the plate down below it, you have to specify contact, and these are uh, I'll do it over 2 second duration and with those parameters that you see there. These parameters for contact. But let's not worry about that right now. So we're going to go to 3DEXPERIENCE. I'm going to go to assembly design. First, I'm going to insert that plate at the bottom. So right click, insert insert 3D part, and I'm going to call this thing the Earth. Earth and Earth. I could have called it contact surface. Right. Let's go make it. So I'm going to go to part design, and on that plane I will sketch. I'll sketch a rectangle, and I'll make it 2 meters on this side. Okay, you fit everything in. There we are. 2 meters on that side and 2 meters on this side. Exit. Now, we can go ahead and make a box down here, but I'd rather put a surface there instead of a box. It makes no difference. It makes no difference. So in order to create a surface, you have to go to, for example, um, generative shape design or something else that allows you to handle surfaces. And there's a surface and there's a fill, and I'm going to fill this. So a surface has been created. Okay. I could have done this thing as a pad and a box and things like that, but I want to show you that surfaces also work. Now, while I'm at it, I'm going to create a point up here, a point in the height with the height of 1 meter. You see why? Because later on, I'm going to place the box over there, the block over there. Excellent. Now we will insert the 3D part. This I'm going to call the block properties. What is this? Properties. Um, block, block and block. Block and block. Okay. And before I make it, what I'm going to do is I'll translate this block to the right. I haven't made it yet, I realize that, but let's try to do that. For example, I can put this thing on that. There we are, you can see that. I did it on purpose so that you can see what's going on. Okay. So this was the Earth. This I'm going to make my block right here for a reason that you see. In fact, what I can do is I can also translate it like this. Okay. All right. There's a reason that I did this. Now on that horizontal plane, I have to go to make my part. I go to the 3D shape. I want to create a box. So let me switch to part design instead of being generative shape design. So on that plane, I will sketch a rectangle or a square of dimensions 0.5 by 0.5. 0.5. Do that, exit, and pad it by 0.5. So there's the Earth, there's the block. Now, while I'm in the block, I create a point at the centroid or the center of gravity of this three-dimensional part right there, because later on I want to place this point at that point, essentially. Okay, good, good. Now, we go all the way to the top. Notice that, well, first of all, why don't we fix this ground or Earth? So let me fix the Earth so that doesn't move. Now, notice that there are no markers here. There's no markers, there's no coordinate system, there's these plates. Yes, I understand that. As a matter of fact, if it's bothering me, I can hide these. Oops, what was that? I can hide these planes, and I can hide these planes if they're cluttering the screen. Good. Now, no markers. Nothing that looks like These things, see these things? And these are not access systems as you are familiar. These are not this, okay? So I'm going to switch. I'm going to switch to motion design. Let's see what happens. As soon as I switch to motion design, and I say okay, immediately some markers are created. One over there, one over there, and it looks like these markers are created at the origin of the part. Remember, origin of my part is here, 0, 0, 0. But remember I translated it? Those plates, see those plates, remember I translated them? They're over here. Okay, good. So this is something new. Yeah. And when I say, remember I told you that you can hide your markers or you can show them, it's this icon. See application, app options. If you click on it, the markers disappear. If you click on it, the markers will come back. Okay, good. Very good. Gravity is applied down here by default. Now, what I'm going to do is I'm going to create a marker right at the centroid because it's more convenient for me to move the centroid to that location. That's what I want. I mean, I can use this, there's no problem with it, but I'm going to use this guy. Okay, so I don't have a marker at that location. See, I don't have a marker at that centroid. So what I'm going to do, I'm going to click on the marker, and it says uh, select the owner body of the element. Actually, let me do there it is, and it says where by geometry, and I'm going to select it and put it right there at that location. So a second marker has been created. I did this. I created this marker, and because I'm going to say this goes there. And I could have used the original one, the default one created, but that's okay. I made it. Now, so here's the situation. Let's go to initial conditions. Initial condition. Now the initial conditions can be defined in terms of markers or in terms of joint. I don't have any joints, so I have no choice but to use marker. And I'm going to choose this marker, the one that I put at the centroid. See that? Right there. Now I can use that, but I don't want to. Click this. Okay, good, good. Under conditions, say translation, let's start with X translation. Position and velocity, because I want the marker to be moved to that location. What is the X of this location? 0. What is the velocity that I want to give it? See, what did I do? What is the velocity that I want to give it? 1 meter per second. 1 meter per second in the X, 1 meter per second in the Y, and 2 meters per second, I believe, in this, and 1 meter per second in the, or 2 meters per second in the Z direction. Okay. Anyway, so this is going to be X position of 0, 1 meter per second in the X direction for velocity. Translation, position and velocity, 0 for Y, again 1 meter per second in the Y direction, and for Z, position is a height of 1. Remember I made this point to be 1 unit up, and 2 meter per second velocity in that direction. And say OK. You might say, wait a minute, well, nothing happened. I did create an initial conditions here. It's right there, you can see that. But nothing happened. If you want this thing to go there, go and do the initial state solve. See that? Initial state solve. Initial state solve. That was this fellow, initial state solve. So click on it. Look what happened. The centroid of that block ended up at the location that I wanted. Now, if you go to the assembly design, This is going to go back to where it was. No markers, it's going to go back to where it is. So you can see these markers are actually only used for the application, motion design application. Okay, good, good, good. Gravity is acting down. We give it initial velocity 1 meter per second to the right, 1 meter per second in the x direction, and 2 meter per second in the z direction. So let's see what happens. We can go solve it. So let's go to simulation. Oh, how many seconds do we want? We want to do it over, let's see now. I wanted to do it over 2 seconds. Okay, so double click on it. Make this default of 5, make it 2, nothing else, leave everything else the same, and then go solve it. Simulation, run. Wait until this it says succeeded, finished. Now select your result. Select your result. Go to Results tab, Animation, and let's see now. Do it, first of all, if you do it all the way, it's going to go through that because there is no contact. It doesn't see anything. Or you can see what happens step by step. So it goes up first because it was 2 meters per second, and then it goes down at a 45-degree angle. There it hits this, and you see that 1 meter per second this way, 1 meter per second this way, 2 meters per second up, and it goes through it. Okay, very good. Now I don't want it to go through it. I don't want it to go through it. So I go back to mechanism. There is a contact here. You select the body, the block, and you select that surface. If this was a box, you would select that box. And under contact properties, you can change the coefficient of restitution, friction coefficient, etc., etc. That is not the focus of this tutorial, tutorial 9. We'll worry about this thing in tutorial 10 when I do an actual example and compare it with analytical solution. So let's go ahead and run it. Go to simulation. You run it. Wait until it goes to 100%. Good. And now we're going to go to results. You select your dynamic step, play animation, and play it. There. And if you want to do it step by step yourself, going up, coming down because of gravity, it's going to hit the surface and it's going to bounce. The bouncing and things like that depend on the coefficient of friction, coefficient of restitution, etc. So you get the picture. The marker is a tool that is used in the motion analysis to do things. And in this particular problem, in this particular tutorial, I showed you how to use it for specifying initial conditions. All right, folks.